Hello friends, welcome to my channel. Let's have a look at problem 1551, minimum operations to make array equal. This video actually is a follow-up video for the video solving problem Leetcode 2449. So here, let's first read through the statement to digest the problem. Actually, after we analyze the problem, we can write the code in one line or just make some mathematical computations. So here we are given an array called ARR of length n, where array I equals 2 times I plus 1. In other words, so this array contains the first n positive odd numbers. So we know that the sum of the first n odd numbers is nothing but n squared, right? So here, in that operation, we can select two indices, x and y, and then we can decrement the number at index x by 1, and increment the number at index y by 1. So the goal is to make all the elements of the array equal, right? So if all the array equal, all the elements equal, so their value should be n squared divided by n. In other words, it equals n. So it's guaranteed that all the elements of the array can be made equal using some operations. So the operation is specified here, right? So given an integer n, the length of the array, return the minimum number of operations needed to make all the elements of the array equal. So here are two examples. So in the first example, so we have 1, 3, 5 corresponding to n equals 3. So after, if we make all the elements equal, so they should be 3, 3, 3, right? So we can subtract from 5 twice and add to 1 twice. So the operation, the number of operations is 2, right? This is the output. Similarly, we can analyze for example 2. So here is a constraint for n. So n is bounded below by 1 and bounded above by 10 to the power 4. So that's actually just for some computational purpose. So let's see the analysis. So here actually we can specify the procedure to make them equal, or we just need to do some rough computation. So let's first look at the analysis. So we are going to use the same analysis process as for Leetcode 2449. So in such a sense, both the two problems are easy in this sense. So we are going to use the invariance again. So here we are going to use that the number of +1 operations equals to the number of -1 operations. So each pair of plus and -1 forms a valid operation specified by the problem. To proceed, let's first make two observations. First, so we have stated that the sum of the first n positive odd numbers is n squared, right? If we want to make all of them equal by the operations specified in the problem, then the final list is a constant list with all elements being n squared divided by n. In other words, m. So this is the one observation. Secondly, we could always balance the smallest one and the biggest one, and so on, right? For example, let's say n equals 4. So we have 1, 3, 4, 1, 3, 5, 7, right? So if we want them to be equal, we need all of them rest at 4, right? So we have constant list of 4, all elements being 4. So we can balance 1 and 7, right? We need to subtract 3 from 7 and put that 3 to add it to 1, right? And then we balance the largest one, that is 5. We subtract 1 and add it to 3, right? So we get 4, 4. So this way we need how many operations we need. So here we need 3 and here we need 1. So total we need 4 operations. So so this strategy is very specific. So we actually can make it we mix the counting without knowing the detail. So we just need to count the absolute difference of each element with the final constant n. The reason is that the number of plus and the number of minus operations are equal, right? So we could divide the rough count by 2. So here, using the above example, so we can do the sum of the absolute difference, right? For example, 1 and 3, 3 and 4, 5 and 4, 7 and 4. So in total it's 8. So among this 8, so there are 4 corresponding to plus and 4 corresponding to minus. So the return should be 8 into the division by 2. So that's the analysis. So we are going to write according to the rough counting and then divide it by 2. So actually, if we do some very elementary mathematics, so if we sum the absolute value, right? So we sum the absolute value. So 2i plus 1 minus the n for I from 0 to n minus 1. So this actually equals n squared minus 1 divided by 2 if n is odd, or n squared divided by 2 if n is even. So this is the writing in a mathematical format, right? So for this problem, we can do it very easily after we digest the above analysis. So we can write using list comprehension. For example, we can write a one line, write the sum, the absolute difference 2 times I minus plus 1 minus n, right? So for I in range n. Then we divide this by 2, right? So let's do a check quickly. So this passes all the test cases. As we mentioned, so mathematically the difference is sort of like n squared divided by 2, right? Either minus 1 or not, depending on n is odd or even. So here, so we actually can directly return n squared integral division by 4, right? Even you minus 1, if you divide it by 2 again, so this 1 does not contribute to an integer. So n squared divided by 2 always always works. So let's comment this out. Let's do a check. Yeah, that's I guess that's about it for this simple problem. So notice that we are analyzing this problem 1551. So using the same idea as for problem 2449. So with that said, I guess that's about it for this video. Thank you.